Hello class, and welcome to lesson 2.2 on percents and fractions. So to begin, I want you to write this down. A percent is a ratio that compares a number to 100. So that's the entire point of a percent. We just did the entire chapter 1 on ratios, which, as we know, ratios are basically fractions. We've got all these things. All of these terms are somewhat interchangeable in the sense that they can be applicable in many different ways. And while you're writing it, I want you to think of this word percent, just like how we were thinking about that word unit, where we know that unit means one, such as unicorn, unibrow, universe, unite, all of those, unicycle, it means one. Try to think about what percent might mean. So let's think about that word percent. Well, first of all, I just want to look at this one. 45%. All that means is 45 over 100, because we're comparing this number to 100. So it doesn't matter. It's not because this is in whatever place, like the hundredths place. It's not anything like that. Any percent, regardless of what it is, you put over 100. Any percent, if it's got the percent sign, you put it over 100. And I'm going to give you a way we can remember that. Let's look at this sign right here, right? This is the percent sign. Watch what happens right now. Are you ready? Watch me. What number is that? What number is that, Dolan?
100.
Look at that. So we managed to go and we can turn the percent sign literally into the number 100. We can turn that percent sign into the number 100. Here's how you go from percents to fractions. Like I said, put it over 100 and simplify. That's it. The entire way to go from percent to fraction is to just put that number over 100 and simplify it. We simplify by finding that greatest common factor. Or you can just keep dividing by any number that you know goes into both until you get to the end. So for example, you might have really big fractions, and you might have the number that we'll see later. You might have these really big percents, really big fractions and stuff like this. And you're like, oh my gosh, I don't know what the greatest common factor is. You don't need to know what the greatest common factor is. Just keep dividing by whatever number. If they're both even, divide by 2. If it ends in a 5 or a 0, divide by 5. They both end in zeros, divide by 10. You see what I'm saying? Think of whatever number you know goes into it. You don't have to think about the greatest common factor for this. So quite simply, to go from percents to fractions, you put it over 100 and you simplify. We're going to break this word down now, just like I mentioned earlier. I want to break this word down. We brought this word up first. What does per mean? What does per mean in P-E-R? Gio, what does per mean?
Each.
Each, it does. Dolan, did you have something to contribute to that?
I was going to say, never mind.
That's okay. Ella, did you have something else to contribute?
Yes.
What is it?
Per means also one.
Yeah. So it means both of those. Each, it means one. So it means both of those things. You know, each student got something. So I gave it to every one person. You know, everybody is their one whole person. They got something. And then the word cent. Dolan, what does the word cent mean? C-E-N-T. Cent.
Cent means,
It's hard to explain, I know, but think about it.
yeah, I know what it means. It's just I don't know how to put it into
Words, I know.
$1. You need 100 cents.
Ooh, so she said something really important right now. She says first that she thinks it means one. Just like with $1, we need 100 cents to make $1. So she said something cool there. Lucas, yes?
Well, the word cent kind of sounds like the word century, which is
Oh,
100.
yes. That's the thing I was looking for. Cent sounds like century. In fact, it is that. It is that. So cent means 100. If you speak Spanish, you'll know that that word means 100 in Spanish. Getting corrected by a CN, but it's spelled kind of similar. We can break these words down. That's because Spanish French, Italian, these follow the Latin roots. So cent means 100. Percent means out of 100. It's the number, whatever one number that we're dealing with, not necessarily just the number 1, but whatever the one number we're dealing with, out of 100. So I want you guys to do this on a separate sheet of paper. I want you guys to find the fractions for these. We think about the initial fraction where all we have to do is put it over 100. So the initial fraction here would be 50 over 100. This one, 55 over 100. And this one is 45 over 100. But am I done here? I see us shaking our heads. No, we are not. Because we have to do what? What is the final step that we have to do, Delaney?
Simplify.
Simplify, yes. Ella, what is the simplified version of 50 over 100?
1/2.
Yeah, 1/2. Their greatest common factor happens to be 50. You can divide them both by 50. What about this next one? 55 out of 100. What do we get when I simplify that, Dolan?
We get
Perfect. So with the combination, we got 11 out of 20. Yes, they are both divisible by 5, and then there is no more simplification. 11 is prime. What about this next one? I want to know, Ella, what's the next one?
I have a quick question.
Oh, go ahead.
It's 9 over 20.
Perfect. So Ben got 9 over 20. He also divided them by 5. Excellent, you guys. Try these ones now. Vahe, what's our initial fraction first for 90%?
Your initial fraction is 90 over 100.
Perfect. And then what's our simplified fraction?
Your simplified fraction would be, hold on. Let me take a quick second because I have to do it.
Gio, can you tell me the initial fraction for 38%?
38 over 100.
Perfect. Jamal, can you tell me the initial fraction for 75%?
Still working on the answer.
The initial fraction.
75 over 100.
Perfect.
Thanks.
As we see, our initial fraction, you don't even need to do anything. Y'all don't even need to do anything. It's just over 100. Vahe, what's the simplified?
18 over 20.
We can get a little smaller than that. Can anybody else give me the simplified? Pearson, yes?
9 over 10.
9 over 10. Whenever we end in a 0, you guys, are you ready? Watch my favorite thing. I just divided by 10. Just cross off the matching zeros. If they both end in zeros, boop, those zeros are gone. This works anytime. If they both end in zeros, you can just cross off those zeros. So,
15 over 20.
ooh, he got 15 over 20. We can get a little bit smaller. Can anybody else tell me a little bit smaller than 15 over 20?
I know it is.
What is it?
It's because you can still divide them by 5, so it'd be 3 over 4.
Perfect. We can still divide them, so we get 3 over 4. Excellent. And Gio, do you have your answer for 38 over 100?
Yeah.
What is it?
Yeah. 3 over 25.
What's the answer?
It is 19 over 50.
Perfect. 19 over 50. They are only divisible by 2. 19 is a prime number, and 50 is not divisible by that prime number, and so that's it. Like I said, we just put our percents over 100 and then simplify. That's the whole thing. Now, let's look at this. So for reading this, the table shows the percent of each movie type rented during a month. What fraction of the rentals were action movies? So the first thing is I've got this whole chart. Do I need to care about this entire chart? With our heads, do I need to care about this entire chart? Yes or no? No, I don't need to care about this entire chart. Exactly. I only need to care about one thing. What's the only thing I need to care about on this chart? Who can tell me? Well, what's the one thing I have to care about?
One thing you can care about is the action movies.
Exactly. All I care about is my action movies. It doesn't ask me anything about the rest right now. So I do not care. I don't care about them at all. So first, what's our initial percent for action movies? Who can tell me? Michaela?
35%.
So it is, we got 35%, and then what's our initial fraction for that?
35 over 100.
Perfect. 35 over 100. That's just the definition of a percent. Vahe, can you tell me what the greatest common factor between both of these are?
They're between 35 and 100, right?
Mm-hmm.
Is 5.
Perfect. So is 5. Divide the numerator and the denominator. We divide them both because what we do to the bottom, we do to the top. What we do to the top, we do to the bottom. So it's the same thing. We divide them both by 5. Who can tell me what 35 over 100 is when we simplify it? Amelia, yes.
Your answer is 7 over 20.
Perfect. Look at that. So we divide them and we find out that action movies were rented 7 out of 20 of the time. So basically that's what it is. That's what the fraction would be. That's equivalent to 35%. Same thing. Now it's always going to be equivalent to 35%. This fraction will always stay the same with that percent. They will always match. 50% is always 1/2. 75% is always 3/4. So let's think about this next part. The question that it's asking us below says write the fraction of rentals that were horror movies. So Romina, what's my initial fraction for horror movies? Perfect, so our initial fraction is 5 over 100. What's our simplified version of this fraction then, Marley?
It is 1 over 20.
Perfect, 1 over 20. I look at these, they're both divisible by 5. It turns out that's the greatest common factor. But I just look at that first and I go, okay, 1 over 20. Excellent, that's how we simplify. Okay. But here's the next part. To go from fractions to percents, you need to make the denominator 100. Technically not make the denominator over 100, but you need to make the denominator 100. That's what I really want. You need to make the denominator 100. This is just using ratio tables. Just like we did before, we're going to be using ratio tables. So let's look at this for an example. 6 over 8. I need to get it to be over 100, right? I need to get this to be over 100. Can I go from 8 directly to 100? What do we think? Remembering last chapter, can I go from 8 to directly to 100? Yeah, I can't go from 8 to 100. Nothing times 8 will give me exactly 100. So I'm going to use a ratio table. I'm going to use my ratio table here. What is the greatest common factor between 8 and 100? Like, what's something that they are both divisible by that I can make it the easiest thing, greatest common factor? Who'd like to tell me the greatest common factor? Who happens to know? Jamal, what is it?
2.
2 is one of them. There is a bigger one. Does anybody know the bigger one? Dolan, do you know the bigger one?
I think so. Is it 10?
It's not 10 because remember, 8 has to be divisible by it. Sophia Kerner?
Is it 5?
It's not 5. Remember, 8 has to be divisible by it. We're close, though. Gio, what is it?
4?
4, exactly. Don't worry. We're still getting used to this. Practice our ratio tables. They both have to be divisible by the number in the middle. So, to get from 8 to 4, what we did is we divided by 2. How do I get from 4 to 100? Who'd like to tell me how I get from 4 to 100? 4 to 100. Sophia Goldstein, do you happen to know?
You multiply?
Multiply by what? Vahe?
I wasn't ready to answer that, but I'll say 6.
4 times, nope, we gotta get 4 times something is 100. 4 times what is 100? Ethan?
25.
Yes, 4 times 25. There are 4 quarters in $1. 4 quarters in $1. So I'm gonna do the exact same here. So Julian, could you please read to me this number that I wrote in red right now? 3, our number in red is 3. And we have to do the next part the same, times 25. When I multiply by 25, 3 times 25, who can tell me 3 times 25? Ethan?
75.
75. So what I found out was that 6 over 8 ends up being 75%. 6 over 8 ends up being 75%. So excellent. Here, I've got another one. 9/12, something over 100. 9/12, something over 100. What is a common factor between these ones? Think kind of just like the last one that we did. What's the greatest common factor? What's something they're both divisible by, Michaela? Exactly, so she's going to divide this by 3 to get 4. Exactly, so we do the same here. I'm going to divide by 3, and I get 3. Now I have to get from 4 to 100. Same thing as last time, times 25. Hey, same exact thing as last time, times 25. And I get my x again to be 75%. So I get 75%. What about this one? 12/40. What's something that they are both divisible by? What is something they are both divisible by? Carly, what are they divisible by?
10.
10, exactly. We divide them both by 10. So I'm going to make this, what I actually want to do is I'm going to divide them both by 4. I'm going to put the 10 in the middle right there because it's going to end up helping with the 12. So I divided this by 4 and I multiply this by 10, right? Everyone agree? Yeah, we see that. That's how we get 40 to 10, divide by 4. And then, because 10 is their greatest common factor, and then 10 times 10 is 100. What we do to the bottom, we do to the top. Here, 12 divided by 4 gives me 3. 3 times 10, so what is my answer then? 3 times 10. Who can tell me the answer? Gio.
30.
30. Excellent. So we get this excellent work that we have. And yes, thank you, Travis, too. This one. Do we need to double jump for this one, or can we just single jump? What do we think? Double jump, hit go slower. Single jump, hit go faster. So yeah, the majority of you say it's a single jump, go faster. How can I go from 25 to 100? How do I go from 25 to 100, Delaney?
You multiply 25 by 2.
Not by 2. But do you know? Romina?
By 5.
Not by 5. We're so close. Michaela?
By 4.
By 4. There are 4 quarters in $1, and quarters are worth 25 cents. It's really helpful when you think about this in terms of money when we're dealing with the hundreds, because we can start dealing with that. So I'm going to do the exact same thing. I don't even need to double jump like I'm saying. I just single jump. 19 times 4. Does anybody know what 19 times 4 is? So I want to see if your hand is up. I'm expecting you to know what 19 times 4 is. So if you don't, put your hand down. Ben, what is 19 times 4?
19.
It's what?
76.
Yes, exactly. And Travis said it too. We got 76. Yes. So we find out that it is 76%. As soon as it's over 100, that's the percent. So guided practice, page 104. The first 3 questions, we have to write each percent as a fraction in simplest form. Always assume that it's going to be in simplest form. Always assume it's going to be in simplest form. But the first things, I'm going to call on random people. Are we ready? And you are going to tell me the initial fraction. I'm going to call on random people, and you're going to tell me the initial fraction. Hannah, what is the initial fraction for 15%? Just the initial. So, Ella, the initial?
The initial is like the fraction.
Yep.
The simplified.
So what's the initial?
Oh, so 15 over 100.
Yep. That's it. The initial is 15 over 100. Based on that, Hannah, what do you think the initial for the next one would be?
Maybe
Ruby, what's the initial fraction for 80%?
80 over 100.
80 over 100. So we got this, Hannah. We got 33 over 100. That's it. Our initial fractions, you just put whatever number you have over 100. 15 over 100. Can anybody simplify that for me? What do we get when I simplify 15 over 100? Who can tell me? Amelia?
You get 3 over 20.
Excellent. We divided them both by their greatest common factor, which was 5. Or we see they end in a 5 and a 0, which means we know they're divisible by 5. Let's think about this. Michaela, what is 80 over 100 simplified?
I did 10 divided by them, so I did 8 over 10.
So she got 8 over 10, so she got that. So Michaela said that it was 8 over 10. Can I get smaller?
Yes.
What do I get?
4 over 5.
Yeah, 4 over 5. So she got down, which was great. She canceled out these zeros dividing by 10, but they're still both even. So we can do that. Gurner, what is it?
I think it's already simplified.
Yes, it is already simplified. We can't get any smaller. The factors of 33 are 1 and 33, 3 and 11. 100 is not divisible by 33, 3, or 11. So we're done. We already got the most simplified version. Sometimes it's already in the most simplified version. Let's look at the next ones. I want to turn these into a percent. So you can use the model, but all of these we're able to do jumps. For these ones, do we need to do single jumps or double jumps? For all of these, single jumps hit go slower, double jumps hit go faster. So do we single jump, go slower, double jump, go faster? We're a little split. Yeah, all of these can be single jumps because all of these are factors of 100. 100 is multiples of all of these. Do you see how they work in reverse? So exactly. Vahe, can you tell me what the percent is going to be for 3/10?
30 over 50.
Not 30 over 50, but you had it. It's 30%. Because what we did is we multiplied it to get it over
Not how to be a fraction.
100. Nope, we're making them into percents. Great thing, though. We got that.
Correct?
What about this one? Eduardo, what is 3 over 20 going to be?
It's going to be 15%.
Yeah, 15%. Because to get this to 100, 20 times 5 is 100. So I do 3 times 5 and I get 15. What about this last one? Do you happen to know, Dolan?
I'm sorry, can you just kind of explain how?
So as we were saying, 2/5. I want to get it over 100. So 2/5 is something over 100. How do I go from 5 to 100, Kayla?
You could do 5 times 50.
We're,
Maybe not 5 times 50. 5 times.
So exactly, we multiply it by 20. We do the same here, times 20. So what would our answer be then, Hannah? Is what?
40.
Perfect, 40. Excellent. So we found out that this one is going to be 40%. Let's look at another one of these so we can get practice. It's asking what percent for this one. This is number 7. It's asking what percent. So I want to make a ratio table. Ratio tables are the easiest thing to do. This one I only need to single jump. I know that because 10 is a factor of 100. 100 is a multiple of 10. They are reversed. So I get 7 over 10 is some percent over 100. Percent is always over 100. I have to always put it over 100. So, Ethan, how do I get from 10 to 100?
You multiply it by 10.
Perfect.
7 times 10 is 70, so it would be 70%.
Excellent. So he got my answer to be 70%. Great job, you guys. Now, for the homework, it's going to be page 105, numbers 1 through 12, all. Okay, so write this down. It's just page 105, numbers 1 through 12. It's all of those, okay?